guys, today we are going to learn all about independent events. By the end of this lesson, you should be able to find the probability of events, specifically independent events. In probability, there are two different types of events, independent and dependent. In independent events, the outcome of one event does not impact the other, whereas in dependent events, the one event is dependent on the other. Go ahead and get out your notes and be ready to learn. Before we get started with this lesson, we've got to review how to multiply fractions because each event is going to be shown as a fraction and we're going to have to multiply. So with multiplying fractions, all we have to do is multiply straight across. This first example, 1 times 3 is 3 and 2 times 4 is 8. So our product is 3/8. The next fraction, 1 times 4 is 4, and 8 times 5 is 40. In this case, this can be reduced. If you can notice that the biggest factor that goes into both of these is 4, we can divide the top by 4 and the bottom by 4. Otherwise, I noticed that they are both even, so at the very least, I could divide them both by 2, and then I'd have to reduce again. So this fraction ends up being 1/10 in the most simplified form. Go ahead and try the next one and come up with the most simplified form. When I multiply straight across, I've got 2 times 3 is 6 and 9 times 5 is 45. Each of those can be divided by 3, so our most simplified fraction is 2/15. Now that we've reviewed the process for multiplying fractions, let's move on to independent probability. Independent probability is when the outcome of one event does not impact the outcome of the second event. The events are called independent. Independent probability can be determined by multiplying the probability of each event happening or probability of A times probability of B. So typically with independent events, you see something as being put back so that our total is never changing. Our total, or our denominator of the fraction, is always going to be the same. So in this case, there are these sets of cards. This is our total of cards. We've got 1, 2, 3, 4, 5, 6, 7, 8. And since in this board game we draw a card and then replace it, and then we draw our second card, this group of 8 is never changing. That's how we can usually tell when it's independent. So the first problem says to earn 50 points, a student must draw a heart-eyed card and then an angel card. So first we're going to figure out what the probability of drawing a heart-eyed card is. So out of our total of 8 cards here, there are 2 cards with hearts. So the probability of drawing a heart-eyed card is 2 out of 8. Then we need to draw an angel card. So again, out of the total cards here, there is 1 angel card, and there is still a total of 8 cards. So the probability of drawing an angel card is 1 out of 8. Now we find the probability of this event occurring by multiplying these two fractions. 2 times 1 is 2, 8 times 8 is 64. This fraction can be reduced though, since 2 and 64 are both even. I can divide by 2 and end up with 1 out of 32. So there is a 1 out of 32 chance that I will draw a heart-eyed card and then an angel card. Now that we've talked about probability being between 0 and 1, so if I actually do 1 divided by 32, since fractions are dividing, I get 0.03. We'll look at this later when we see what has a better chance of occurring. Just for our reference later, I went ahead and put this little number line here where 0 is impossible, 1 is certain. So with this being 0.03, it's pretty close over here to the 0. Let's move on to number 2. It says to earn 20 points, a student must draw a sleeping card and then an angry card. Go ahead and figure out what is the probability of drawing a sleeping card. There are 2 sleeping cards, and there are still 8 total cards, so our probability of drawing a sleeping card is 2 out of 8. Now see what is the probability of drawing an angry card. The probability of drawing an angry card is also 2 out of 8. There's an angry card here, and there are still 8 cards. Now, find out what our probability of these events occurring together is. The probability here is 4 out of 64, or 1/16. This is 0.06. as we can see, this has a better probability of happening than this one does. Question 3 says, to earn 15 points, a student must draw an angry card or a laughing card and then an angel. So we've got something a little different going on here because we've got two events occurring kind of together. That for the first draw, you're either looking to get an angry card or a laughing card. When you're looking in the total of cards up here, you want to find laughing or angry. And so when you do that, we've still got these two angry cards and we have this one laughing card. So in my first draw, there are 3 out of the 8 cards that I'm looking to draw. Then we're going to draw an angel card, and again, there's just this one angel card here, so the probability of an angel card is 1 out of 8. I find the probability here, I have 3 out of 64, or 0.04. The final question says, to earn 5 points, a student must draw a sleeping card or a hard-eyed card, and then an angry card. So again here, we've got where we're okay with, in our first draw, to either get sleeping or heart. And when I look up here in the set of cards, there are 2 sleeping cards and 2 heart cards. We still have a total of 8 cards, so for my first draw, I have a 4 out of 8 chance of getting a card that I need. Then we're going to draw an angry card. When I look back up in my set of cards, there are the 2 cards that are angry, so that one has a 2 out of 8 chance of happening. Multiply these events together, I have 8 out of 64, which reduces to 1/8. When I find out the decimal form of that, I have 0.125. So this event is the furthest away from 0, or the largest probability of happening. On the back of your notes, it is one of these where it says to play tic-tac-toe with your neighbor, but I'm going to go ahead and do a couple of these with you, since instead of having cards laid out, there are a few scenarios that we need to think about, and then we'll finish the rest of the problems together in class. So for these events, we may not have the same denominators like we did in the first problem. In the first problem, we were always getting out of 8 cards. But here in the first problem, it says, Kylie has a coin and a number cube. She flips the coin once and rolls the number cube once. What is the probability that the coin lands tails up and the cube lands on a 4? Problem, we still have 2 things happening. So we're still going to have 2 fractions that we're multiplying together. But our first event is flipping a coin. And with a coin, there's 2 possibilities that could happen. We could either get heads or we could get tails. So the denominator of that fraction is 2. That's for flipping the coin. We're going to roll a number cube. Well, a number cube is a dice. So if you think about how many numbers there are on a dice, there are 6 sides. So I could get up to 6 different scenarios here. So that fraction is going to have a denominator of 6 for rolling the number cube. And this question wants to know, what is the probability that the coin lands tails up and the cube lands on a 4? Think about the first event, which is flipping the coin, and it says that landing tails up. Well, landing tails up is a 1 out of 2 chance. One side is tails and the other side is heads. Then the cube landing on a 4, well, if you think about a dice, there's a side with a 1, a side with a 2, side with a 3, side with a 4, and so on. So there's only 1 chance that it's going to land on a 4. So here we've got a 1 out of 2 times 1 out of 6. Here we just go ahead and multiply straight across. 1 times 1 is 1, and 2 times 6 is 12. So our probability here is 1 out of 12. Going to go down this row. The next one says, what is the probability of flipping 3 heads in a row? So in this problem, we have 3 events happening, whereas in all of our other examples, we've only had 2. So each probability is flipping a coin. So each chance is out of 2. So our first time we flip it, we have a 1 out of 2 chance of getting heads. The next time, we also have a 1 out of 2 chance of getting heads. And then the final time, we have a 1 out of 2 chance of getting heads. So now we need to find the probability of flipping these 3 coins in a row. So we can just go ahead and multiply these 3 fractions straight across. When you multiply these fractions straight across, you've got 1 times 1 times 1, which is 1, and 2 times 2 times 2, which is 8. So the probability of flipping 3 heads in a row is 1 out of 8. The next problem going down says the letters of the alphabet are written on cards and placed in a brown paper bag. What is the probability of drawing a vowel, replacing it, and then drawing another vowel? So for this problem, we have two events occurring, our first draw and then our second draw. And it says it's the letters of the alphabet. Well, in the alphabet, there are 26 letters. So in our first draw, there's going to be 26 letters. Then we put that card back and we draw again. So there's still going to be 26 letters. Then it wants to see what the probability of drawing a vowel is. Well, the typical vowels are A, E, I, O, U. So that is 5 of the cards. Since we're drawing a card and then putting it back, there should still be 5 vowels in that stack of cards at the end. So our probability of the first event is 5 out of 26, and the second event is also 5 out of 26. We'll go ahead and do this next problem, going to the right. Here it says 2 number cubes are rolled sequentially. That means one after another. What is the probability that the first number cube shows a 2 or a 3, and the other number cube shows an even number? First, let's think, how many events are there? Well, there's 2 events here because we have 2 number cubes. So our first event will be multiplied by our second event. The first event wants to know what is the probability of the first number cube showing a 2 or a 3. That first event is where we're looking for one of 2 things to happen, a 2 or a 3. So there are 6 total sides to a cube, and I'm looking to roll either a 2 or a 3. So there are 2 different sides out of those 6 sides that I want. So my first event has a 2 out of 6 probability. Then I want the other number cube to have an even number. And that probability is 3 out of 6. We've got 2, 4, 6 that are even, so I'm looking for it to either land on 2, 4, or 6. Next, when I multiply straight across, I've got 2 times 3 is 6, and 6 times 6 is 36. This can be reduced to 1 out of 6. Finally, I want you to go ahead and try this last problem here all by yourself. Mackenzie chooses 1 candle, returns it to the bunch, and then chooses another candle. What is the probability that Mackenzie selects a polka dot candle both times? In this problem, there are 5 total candles, and 2 of them are polka dotted. So on my first try, I want to get one of the 2 of the 5 candles because they're polka dotted, and then I put it back, and then I try again, and I again want to have 2 out of 5 of those candles. Probability of these events occurring is 4 out of 25. Now that we've made it to the end of this lesson, let me know, would you rather save or spend your money? In this lesson, independent events, you should now be able to find the probability of events. Specifically in this lesson, we looked at independent events, and this is where the outcome of one event does not impact the outcome of the second event. This is when events are called independent. By doing this, we multiply the probability of each event happening. Each event happening is a fraction. So we looked at where we had a card, and we might have drawn 1 out of those 8 cards, and then when we tried again, we might draw 2 out of 8 of those cards. And we find the probability of those events happening together. Let me know if you have any questions. Bye, guys.